Okay, so I'm going to try and explain the blockchain and demystify it really in some ways because there's a lot of jargon around it and misconceptions, misunderstandings, and so on and so forth. So this is an attempt to just try and put it into everyday language. So I'm also calling this as a tidal wave is coming. Just my personal belief that this is fundamentally a technological revolution, the likes of which we haven't seen since the invention of the internet. Okay, so what is the blockchain? So let's just get some background. Back 10 years ago or so, a guy by the name of Satoshi Nakamoto, or at least that's what we think he's called, he remains anonymous to this day, published this paper, peer-to-peer electronic cash system, which set the foundations for Bitcoin and the what has become known as the blockchain technology. So this was the world's first implementation of a blockchain for a cryptocurrency. Just Satoshi Nakamoto, by the way, to this day has not revealed himself. No one quite knows whether it is in fact a real person or maybe a group of people, and so on. But there you go. So what is the blockchain then? So we can think of it as kind of a book, a record book, or a ledger, somewhere where you can actually write down entries, where each entry is significant because it's a record of some sort of exchange of value between two different parties. The thing about this so-called record book or the blockchain is that there are multiple copies in the thousands, if not hundreds of thousands, around the place that contain the very same information or data. And this is maintained by, let's call it a community of record keepers, right? Now, in the blockchain world, they're called miners because they mine Bitcoin, but that's a different subject. The point being that all of these copies are synchronized. So every time a new entry or a new block is created, it requires proof of work, which basically means that this community then comes together in a sense and checks that the transaction that is to create the new block or add to the existing block is in fact valid. So consensus is required. The other thing here, of course, is that because of the way this is distributed, there is no single entity that actually owns the information. So in actual fact, that there are multiple decentralized instances of the same information. So in the little diagram here, we've got, if you like, the traditional database concept of a centralized storage of data with all the nodes, pointing back into the data set. But in the decentralized and distributed example, which is the blockchain, you can see it's everywhere. So the blockchain is decentralized in this way. It's replicated where each node corresponds to the same version of the actual blockchain at all points. So very much highly distributed as well. An example of what the blockchain could be in terms of everyday sort of an everyday example would be, let's say that Peter, which is our chappie here in the white suit, grey, wants to pay Paul $100. But they don't want to use a bank, and they are also interested in making sure that the transaction is recorded accurately for posterity, for whatever reason. So they get together, a group of their friends, which they all come together with their record books, and they witness the transaction and record the details in their little books. Now, each book now contains the detail of the transaction as a new entry, as a new item added on to however many entries they already had in their books. This means now that if you want to make a change to the transaction, let's just say a malicious change, somebody wants to change the value from 100 to 1,000 or $1 or whatever, or change it in whatever way, the date and time or the parties involved, would need to change all the books at the same time, which you can see that would be difficult when you're talking, in the case of the actual blockchain, hundreds of thousands of instances of that information. So pretty much nearly impossible. Okay. Other critical features of a blockchain are that when the new entry comes onto the blockchain, it effectively becomes immutable once it's recorded on the blockchain. Now, what that means is that whilst you can still make changes, you can't make a change without requiring complete verification of that change, which is the proof of work, across the entire community of verifiers or miners, as they are called, to actually ensure that the change is valid. There is another point to this as well, and that is that the way that the blockchain is built is such that any block on the chain contains information that points back to the previous block. So there is this continuous sort of linkage or pointers, if you like, from any block to its preceding block, so that a change anywhere on the blockchain will require changes to preceding blocks. You can see where the difficulty then becomes, because all those changes would need to be verified by the community of verifiers, or the friends in the case of Peter and Paul's transaction, and there are a lot of them. So the thing also to know here is that the access to entries on the blockchain is via a unique cryptographic key, which is also known as a hash. Now, a hash is effectively a string of characters that is produced via the execution of a very complicated algorithm that produces fundamentally a unique set of these strings of characters, and that is used in order to validate. And it's impossible, in practical terms, to actually reproduce a hash randomly or by brute force, trying to sort of go through different versions of this long string and then by chance happening onto the one that you're looking for so that you can crack it or hack it. It's in practice, it's impossible. We've already said the blockchain is a continuous record, and which means that any block anywhere on the chain basically contains the hash of the previous block, which makes unauthorized changes pretty much impossible, because you would have to change history as well. Okay, so why should anybody care? Well, if you look at the world the way it is at the moment, particularly with personal data and the use of social media in particular, we surrender our personal data to third-party entities such as, Google, Facebook, and so on. But not just third-party social media entities, but things like banks and governments and so on, all have a piece of data, our data, and fundamentally we have no control over it. Furthermore, any transactions or exchanges of value or information need to be mediated by these third parties. And usually that comes at a cost. So, usually there'll be a monetary cost and also a cost in terms of time. For instance, if you're doing international transactions or funds transfer from Australia to the UK or whatever, it's going to take a few days or whatever for it to clear through the process. Whereas if you were to do that on a person-to-person or peer-to-peer sort of basis, it's almost instant. Not quite instant, but almost. The other thing, of course, is that with the data being out on the cyberspace, you fundamentally have no control over your own data. Once it's out there, it's out there. So that's one of the things that can be addressed by the blockchain, is the fact that the data is now secure and accessible via this unique key, but gives you control. Now, the blockchain itself has no single point of failure. As we pointed out before, with the way in which its architecture being highly distributed, replicated, it means that even if there are faults or blackouts of a bunch of computers in that entire network, the reality is that your data is still somewhere because it's been replicated many, many, many times over. In fact, hundreds of thousands of times. So there is no single point of failure. You would have to knock out the entire internet, I suppose. But other than that, it's pretty much everywhere. So the blockchain is technology that can apply to virtually any endeavor or any industry that has a requirement for trusted record keeping. So anything where there is going to be value exchange of information, and you want to be able to refer back to it at some point later, and you want to be able to trust that the information is accurate, and that it is accessible and it can't be hacked, then the blockchain is your answer. Currently, if you want to do that, you have to go through a third party. So, you trust the bank. Well, perhaps you don't trust them as much nowadays, but you trust a bank to keep your money and to keep a record of the transactions that have taken place through your account. The blockchain can take care of that. Okay, so some use cases here. And as I said before, basically every blockchain, every industry is amenable to being disrupted by the blockchain. We can see here we've got legal, supply chain, government, energy, retail, food, healthcare, insurance, travel and hospitality, education. You'll find that just about all of these currently there's either some work going on to come up with blockchain solutions to specific problems within that industry, or there already exist solutions. Energy is one that comes to mind. There's a cryptocurrency called PowerLedge that allows for peer-to-peer transactions of energy. So if you've got surplus energy, rather than selling it back to the energy provider, you can do a blockchain transaction, and that's effectively a contract that gets onto that blockchain and so on. The point being that that is now there, it's available, and can be accessed. So I hope that gives a very high level overall view of what blockchain is, what it is, what it's about, where it's at, and some of the future. Wasn't meant to be a technical discussion by any means, just simply an overview in everyday language to introduce somebody who is not familiar with the idea of blockchain to get to a point where they can sort of start to understand what blockchain is. Okay, thanks.